All right, shout out to Natalie and Forrest. Is that it? Jasmine. Hope you guys are doing well. Emma's got a birthday on Friday. She's bringing treats, and she's dropping out of school and get married. No. Okay, just bring treats. Just a treat thing. Okay, all right. Got it. Okay, let's open up this sheet. Oh, good times. All right, here we go. So these are your graphs. This is what you're going to reference during the course of the test. So this is your secant graph. Again, I drew the axes on there. Then this is the cosecant graph. Again, I draw the axes on there, and you can see that. Do you remember what those vertical lines are called that the graph approaches but doesn't actually touch? Asymptote. And so you can see that these graphs have asymptotes too, and we'll talk about why in a second. All right. But then they have these U-shaped things as well. And the directions for graphing secant, cosecant are right there. It looks lengthy, but it's really not that bad. You guys are going to find this to be pretty straightforward, and it all centers around your ability to graph sine and cosine, which is really good. So let's talk about the basic graphs for secant and cosecant. The graph for y equals cosecant is going to look very similar to this graph, y equals sine of x. Anybody know why I chose sine? It is the reciprocal of cosecant. Okay? Sine and cosecant are reciprocals. What's the reciprocal of secant? Cosine. So starting to graph secant and cosecant requires that you first start graphing sine and cosine. So in order to sketch this graph, we're going to start with sine. What is the amplitude of sine? How high up and how low? 1 unit. What is the period of sine? 2 pi. Okay. Where does sine start? Max, the min, or the middle? Starts at the middle. So I'm going to draw sine graph. I'm going to draw a dotted graph because we're not actually graphing sine, we're graphing cosecant. So this is not the graph, but I'm going to use it to generate the graph for cosecant. Here's where you have to start thinking. Okay? Everybody ready? What is the height of the function right here? 0. From what we learned yesterday, what is the reciprocal of 0? Undefined, right? If you take the reciprocal of 0, you get undefined. So if sine is equal to 0 there, cosecant is undefined. So I find all the spots where sine is equal to 0. And wherever sine's equal to 0, cosecant will be undefined. The way that I show it's undefined is I draw those shapes. Vertical asymptotes. Still haven't drawn any of the graph in cosecant yet. I'm just giving the skeleton. But now I can draw the actual graph. I'm going to start right here. What is the height of the sine graph right here? 1, or 1 over 1, right? What's the reciprocal of 1 over 1? 1. So cosecant and sine actually do share a value of 1. I'm going to move just to the side of 0. Is that a really big value or a really small value? So it's like 1 over 100. What's the reciprocal of 1 over 100? 100 is a really big number. So you can see that we are going to get that type of shape. And it's the same thing down here. What is the height of sine right here? Negative 1. What is the reciprocal of negative 1? Negative 1. So therefore, do that. So all I end up doing is just drawing the asymptotes and then drawing U-shapes at the max or the minimum values of sine and cosine. So which color do I have up on the board that actually represents the real graph of cosecant? Black graph. The rest is just the skeleton that we used after we draw it. Secant. What should I make a graph of to start out? What's the reciprocal of secant? Cosine, right? So I'll draw a graph of cosine. Anytime I see cosecant, I do sine. Anytime I see secant, I do cosine. Where does cosine start? The max, the min, or the middle? The max or the min, because it's positive, it'll start the max. Go down. After I sketch my graph of cosine, I mark the spots where it crosses 0, where it has a value of 0. You tell me when I get to one of those spots. You do that again. Who did that? Do it again. Yeah, do it again. One more time. So that's our buzzer. We beep it. So wherever it crosses 0, that's where the graph of secant is undefined. And wherever we have, you know, maximum values for the graph, put a dot and U shapes going up. And wherever we have minimum spots on the graph, we put dots with U shapes going down. What do you think? Yes. These are the parent functions. They model exactly what we have right here. So the parent graphs for secant and cosecant are listed right here. Now this gives you the instructions for these type of graphs of secant and cosecant, amplitude and period, horizontal shift and vertical shift. That's all the same as sine and cosine. But this tells you the steps. Draw a graph like sine and cosine, which we did. Draw asymptotes where it's equal to 0. And then draw the U-shapes at the max and min. Those are the steps. So do you see why it's important to know how to graph sine and cosine if you want to do that? Excellent. So let's flip to the back. Let's do a couple problems. Such as work. Yep. We'll just shorten the notes. Give you guys goals to give you a little bit of time to work today, so I'll try to shorten this up a little bit. So the first I have to decide is what I start to graph. Do I graph sine or cosine? Sine, and I'm going to graph 2 sine. What is the amplitude? 2. Now watch, it used to be that I marked my amplitude way up there. But if I did that, I wouldn't be able to fit my U-shapes on, would I? So I try to give myself a little bit more space this time. I choose to put 2 right there. You see what the period is. 2 pi divided by your b value, so it's just 2 pi. Is there a horizontal shift? Is there a vertical shift? No. So therefore, all I need to do is just graph my sine graph. Start max, min, or middle? Middle. Got my sine graph drawn. What's the next step? Yep, you draw your asymptotes through the zeros. 0, 0, 0, 0, 0. So asymptote, 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 asymptote. There's just 3 steps. There's graph sine or cosine. There's draw the vertical asymptotes. The last one is start your U-shapes at the top and at the bottom. Yeah, and as you look at it, isn't it impressive? I mean, as you look at it, doesn't that look like something that's complicated? Like if you showed this work at your parents, they might say, "Wow, you're like a National Merit Scholar." Yeah, you're really smart. You're intelligent. We did something really good. If you know how to graph this, then A+ for us. Right? Yeah, I mean, it looks tough. you show that, to yourself 2 years ago when you're sitting geometry, you'd be like, no, there's no way I'll ever take that class. But you can see what you're capable of. Okay, we're capable of doing really good stuff here. Okay, this is tough. So, we'll do the next one. Instead of graphing sine, what should I graph? I'm going to graph y equals negative 3 cosine of 2x. Okay, so I just switched the graph to cosine. Amplitude, 3. Period, pi, very good. Is there a horizontal or vertical shift here? No, there's not. So as I marked it off, half of pi is pi over 2. Half of pi over 2 is pi over 4. And then I counted 1 pi over 4, 2 pi over 4, 3 pi over 4. Good, yep. It's practice. There's no horizontal shift. There's no vertical shift. So what I'll do is I'll just start by sketching cosine. Is this graph going to start at the maximum, minimum, or middle? It's going to start at the minimum. Cosine starts at the maximum because it's negative. It's going to start down at the min. My next step. Zeros and asymptotes. And the last step, U-shapes. For the last one. The last one has a horizontal shift and a vertical shift. We'll just give it our best, okay? You will not see a problem that's difficult on the test. Okay? But I think we should still at least try. Okay? So let's challenge ourselves and do our best. Instead of graph 9, we graph y equals negative 4 times the cosine of 2x plus pi over 2 plus 2. Why did I switch the graph to cosine? Because it's the reciprocal of secant, and you create that skeleton. Okay, good. All right, so since this one has a vertical shift, I'm going to do that first. What is the vertical shift? 2. What is the amplitude? 4. So what will be the largest value that it will reach? 6, and what's the smallest value? Negative 2. So I'm going to mark it like this. I'm going to go 2, 4, 6, negative 2. And that vertical shift of negative 2 will be like this. Remember when we set them up like that for sine and cosine? Same type of business. We add 2 to, or we add 4 to the vertical shift, and we subtract 4 from the vertical shift. That tells us our maximum and minimum values. Okay, question. The period, 2 pi divided by 2. I get. I'm going to mark off pi at the end. about 2/3 of the way. Just doing that because I just want to give myself space here because there's a lot of stuff. That's why I made it so big. True or false? There's a horizontal shift. Okay, now we kind of hit DEFCON 5, folks. Because do you remember when there's a horizontal shift? Do you remember what type of graph we make first? A ghost graph. But then you're also supposed to make a skeleton after that for the rest of the graph. So we're going to end up with a lot of dotted lines on here, aren't we? So now that we've applied the horizontal shift numerous times, I'm going to show you an easier way, now that you've had practice at doing the horizontal shift. Don't dare say you should have shown us that the first time, because I've done that plenty of times in previous years and people don't get it. Okay? So now you've shown the ghost graph. If you'd like to do this from now on for your horizontal shifts, go ahead. Instead of making a ghost graph, I'm going to find my horizontal shift. I take 2x plus pi over 2, set it equal to 0. I get 2x equals negative pi over 2. So x is negative pi over 4, correct? Okay, divide by 2 is the same as multiplying by 1/2. Right? So if you want to get rid of the 2, you multiply by 1/2. You get negative pi over 4. Horizontal shift. So how much of a tick mark is pi over 4? It's 1. Since it's negative, it's going to go in the left direction. So here's what I can do. Where does cosine want to start? Max, min, or middle? Minimum here. So it wants to start right here, right? But I'm just going to do the shift right now. I back it up how many spots? 1 tick mark. And then I continue on my pattern. That way, instead of showing 2 dash graphs, I just show 1. That's how you would want to graph it, right? Cosine starts at the bottom, right? Well, that is, I took that first spot down at 0, negative 2, and I backed it up 1 tick mark. So I backed it up to here. And then I carried on with my pattern. Up, up, down, down, up, down, down. Okay. I have 2 steps left. Now I'm going to mark, here's a trick, you don't mark where it crosses 0, you mark where it crosses the axis of rotation. Now we mark our max and our mins. And that's a really impressive graph when you consider negative 4 secant of 2x plus pi over 2 plus 2. It's not easy stuff. As I said, you will not receive a problem that difficult. So if you understood how to do that, you are super good to go for this test. But now it's time to practice. You've got a few days to practice stuff here, right? And you're going to get some time right now to work on your assignment. And try to keep that assignment nice and short. Okay, I pause the video. I'm going to bring up the assignment. Okay, there's your assignment, 1.6, page 187, 11, 13 through 16. So this date, Tuesday, November 10th, that's when I had it first semester. So we'll do the same assignment. It's only 5 problems. And get ready to go tomorrow.